Hi everyone, welcome to the Machine Learning with Spark on Google Cloud Dataproc workshop. We are just 6 o'clock and I'm just going to wait for a couple of more minutes to see if more people will join, and then we'll start with a little intro for today's workshop before we go through the hands-on workshop. So hope everyone's fine. Just a little before we start, if anyone has any question, you can pop it in the chat on the side. And we'll make sure to have everything answered today. A little maybe opening. What we can do is everyone can pop in the chat from where they are joining us from. Like me, I'm joining in from London today. Okay, we have a couple of more from London as well. Someone from Kent, Tim, who will be one of the hosts today. We'll shortly introduce him. He will be helping with answering questions today, and he's joining from Bristol. Oh, from France. Hello, welcome. Okay, just in the interest of time, I think it's safe to start right now. Even if anyone will join late, we'll be on time just for the workshop. So welcome to the Machine Learning with Spark on Google Cloud Dataproc workshop today. And just a little info about the host today. So my name is Goran. I'm from GDG London, and I will be the host today. Today joining is Ricardo as well, who is from GDG London, and he will be managing the YouTube streaming side and picking up any questions and answering questions there. And also we have Tim, who is from GDG Bristol. He will be helping me here on the Zoom call with answering any questions that you might have. A little housekeeping before we start today. So there will be a little content of presentation sort of for 20 minutes sort of. We'll be aiming to finish that. Then we will be going for a 40 minutes walkthrough on the lab from Quick Labs, and we should be have around 1 hour of workshop where people can do sort of a self-paced workshop, or if you have any questions you would like to be answered, concerned. Like I mentioned, for any Q&A, write your questions in the Zoom, in the YouTube chat. We do have a code of conduct, and you see the links. So we would ask anyone to please follow that. So diving into the presentation for today. So let's imagine for a second that we've got the problem of predicting the probability of heads for some coin flips where maybe the coin is slightly bent. So in order to predict the probability, we might use features like angle of bend, maybe a coin mass, all kinds of stuff in there. So what's the simplest model that you could think of using? So maybe we can use linear regression in this case. But if we would use a linear regression, there might be some weird things in there. For example, what if we have a coin that we're predicting on that has a very heavy mass, that heavy mass that we've never seen before? Or what we have an extremely large band of the angle? So we might end up with predictions that are outside the range 0 to 1. So as we know, that will be a really weird for probabilities, because probabilities are a special thing. Probabilities, they are bounded between 0 and 1. And if we have a prediction model that gives us a value outside of the range, then we're going to be sort of in trouble, especially if we say try and multiply predicted probabilities or use them to create expected values, sort of like that. Well, as a first hack, what we can try, we can cap that prediction to ignore any outlier values. But now we've introduced bias into our model, and we're not going to be very good there. So really the right thing to do is to come up with a slightly different loss function and prediction method. So this different loss function and prediction method should allow our values to be interpreted naturally as 0 to 1 probabilities and never exceeds that range 0 to 1. So we call this idea logistic regression. So logistic regression is a prediction method that gives us well-calibrated probabilities, and these are, so to say, fantastically useful. We can use these as real probabilities and multiply them with things to get expected values. We can use them also for things like classification tasks, where we really want to know the real probability that an email is spam or not spam. So let's take a little look of how this might work. So we take our familiar linear model and we stick it into a sigmoid. So a sigmoid is basically something that gives us bounded value between 0 and 1. So there is also asymptote, as we can see from the little graph on the side, that so it never quite hits 0, and also it never quite hits 1. So having this in time at a training time, so we are training using a different loss function. So as we mentioned before, square loss is not going to really cut it here. So we lose something called log loss. So that is, if you have a little closer look at the formula over there, it looks very similar to Shannon's entropy measure from information theory. So now we don't necessarily need to understand the math to be able to take a look at the graphical interpretation, because if we take a look, we will notice that as we get closer and closer to one of the bars, the loss gets very, very high quite quickly. So again, like we see those asymptotes coming into play. So those asymptotes are actually quite important to think about in terms of learning. So because of those asymptotes, we will need to really incorporate regularization quite explicitly into our learning. So if you don't incorporate regularization, then on a given data set, the model may try and fit our data ever more closely, trying to drive those losses near 0. So L2 regularization can be extremely helpful here to make sure that our weights don't go crazy out of balance. So why do we like this introduced linear regression? Well, one thing is that the real linear regression is that it's really fast. It's extremely efficient to train, and it's efficient to make predictions. So when we need a method that scales well to massive data, or that we need to use for extremely low latency predictions, linear logistic regression can be a great choice. But if we need non-linearities, we can also get them by adding in feature cross products. So that is sort of introduction that I would like to mention here for linear logistic regression, just because in our lab, we will be using this logistic regression with Spark on Google Cloud Dataproc. So before we dive into the code lab, just a couple of introductions for the tools that we will use. So we will use a Google Cloud Dataproc. So if you're not aware, Google Cloud Dataproc is a fast, easy to use, fully managed, and highly scalable service where we can run Apache Spark, we can run Presto, Apache Hadoop clusters as well in a simple and also quite efficient way. So we can use Dataproc for data lake modernization. We can have a secure data science, and it's also quite easily scales on a global level. So this is a fully integrated with Google Cloud, and the greatest thing when using a Dataproc is that there is a advanced security like we can use such as Kerberos or Apache Ranger or personal authentication, but also even though using it, it introduces quite a cost, but not that much. It is also chargeable by seconds, which means that we do not get chargeable for something that we haven't used, which is quite great when it comes to this product. Next thing that we have is Apache Spark. So Apache Spark, probably everyone aware of it, is been a while. It's been around for a while. It's an analytics engine for large scale data processing. So Apache Spark achieves high performance for both batch and streaming data, and it's actually has a very good query optimizer. So Sparks offer over 80 high-level operators, and we can use it interactively from Scala, Python, R, even SQL shells. And also there is a lot of libraries, including SQL data frames, MLlib, which we'll be using today for machine learning. And we have Spark streaming and different as well. So we can also combine all these libraries seamlessly in the same application. And as we mentioned before about logistic regression is available as a module in Apache Spark's machine learning library, which is MLlib. So Spark MLlib, also called Spark ML, includes implementations for most standard machine learning algorithms such as k-means clustering, random forests, least squares, alternative least squares, decision trees, etc. Spark, when it comes to the cloud, Spark can run actually on a Hadoop cluster, and that Hadoop cluster is Google Cloud Dataproc, which is a solution built on Hadoop cluster. So in order to process very large data sets in parallel, even though we will not be using a lot of large data sets today with our lab, it's good to know that this one can be quite useful. And as you can see from a little graph that I have included in the slide over there, we will be able to see that running logistic regression in Hadoop and Spark, there is quite a huge difference. So running Hadoop usually takes around 110 seconds, whereas Spark is less than a second, or 0.9, which is quite great to see. So overall, that would be an introduction and what we will be seeing today in the lab. So before we start and work through together on the lab, just gonna stop to share right now. Just see if there is anyone any question in the chat before we start with the other.
Hi there. You mentioned in the beginning that you will get probabilities that are outside 0, 1. Why would you get that? Can you just highlight? Maybe there's some fundamental here I'm missing. What way are you going to get that probabilities outside 0, 1?
Yeah. So well, it's not about that because we know the probabilities is between 0 and 1, but it was literally that one direct to my example. For example, like if we have a bent coin flip, right? So what we would do if we have a mass on that bent coin flip, and that mass is like very large and we haven't seen it before, how would we have the probability on that one? So that's why we can literally sometimes get crazy results when it comes to that, being honest with you. So that's why just having the logistic regression and will be something that we can that can sort of avoid this, so to say.
Right. Okay.
Yeah.
Okay. See. Yeah. I can see the smoothening of the smoothening of the curve, and then the regularization you mentioned there.
Yeah.
Right. Okay, thank you.
All right, great, no problem. Yeah. Okay, so if anyone else has any question, please feel free to post it into the chat. So what I will do right now is just going to start to share my screen again, and we can start off. So as we mentioned, see, okay, perfect. I hope you'll be able to see me, see my screen. So as we mentioned before, we'll be using the machine learning with Spark on Google Cloud Dataproc. So as this will be with apps, we would like everyone to join in advance. So I just put in the chat the link to that to the lab. So as you can see from my side, I have it my one open in incognito window just because it's easier. So what I have done previously is that I have opened Quick Labs in incognito. I have logged in as myself, and I have opened the lab. So it will be easier when I will be navigating to the Google Cloud platform. I will be able to do it within the same incognito window, so to say. So just let me know if anyone has any issues while getting there. Just gonna pause here for a second before we continue on the next bit.
So you mean we need to open Google Quick Labs?
Yes. So if you go to google.quicklabs.com, just log in. So what I have done, I have opened an incognito window. I logged in with my account, and I have posted in the chat the link to the lab. So if you can just open in that one, just copy paste in incognito, and don't click start lab yet. Just wait until I'm going to share my spreadsheet.
All right. So instead of join, we just sign in.
If you do not have an account with Quick Labs, you will need to join. So have you ever used Quick Labs before?
Yeah, I've used before, yes.
Yeah, so just go ahead and sign in with your account that you have, or if you would like to have a new account to create it, feel free to do that. But in the interest of time, just gonna also share the codes. So as you can see in the chat, I've created a little list with everyone that have registered for today's lab. So once you're gonna find your name, there is a little box of attending. So for example, I have put my name on the top. So just click attending, that you will be using that voucher code. So no one else will be using that one. And shortly we'll let you know how to activate the lab with that code. For a little convenient, I have posted the link for the lab as well over there. So it's up to you if you would like to navigate to the lab from the Zoom chat, or you would like to navigate from the little spreadsheet. Okay, so I can see that we have quite a few over there. So the voucher code that is associated with your name can be used just when starting the lab. So in the interest of time, so once you click Start Lab, Quick Labs is asking you to just confirm it's not a robot, which is great. Perfect. That's a little there on the top. Hopefully we'll not miss that. So we have a credits, which means that, hey, you have this many credits, you can launch the lab with the credits, or you can add to the lab access code. So funny thing here is that you will not be able to copy paste the lab access code. So it's just better to type it. So if I start to type 27 for my one, Okay, so I would say that one has, I have actually entered it correctly. So if I do launch with access code, which looks like it's okay, then I should see up here the lab started. There we go. So because of this lab, there is a couple of requirements or lab resources that will need to be provisioned from Quick Labs on the Google Cloud Platform. And this one will just take a little, just before we'll be able to access the login details. So what Quick Labs does is that creates us a temporary Quick Labs login for using the resources on the Google Cloud Platform. And the great thing here is that we'll be able to gain hands-on training without using resources under our account. And just because a couple of them, for example, like Google Cloud Dataproc requires to have a billing enabled, although there is a free tier, we would, if we would like to do much more, then we will be maybe billed for that seconds or minutes that we have used. So that's a quite good thing when it comes to that. Just so anyone, yeah, just as Steve mentioned into the chat, if you don't see your name on the list over there, just let us know, and you will be able to allocate any other voucher for it. So I'm just going to be closing that. And what I will do here, just because we have the little open Google Cloud Console, but you can navigate manually as well by going to console.cloud.google.com. So once I'm there, I can use the temporary username and password that have been provided from Quick Labs. So simply copy and pasting. Should be able to log in. Couple of things to notice here is that, as you see, this has been a temporary made account. You need to accept the terms and conditions over here. And just because it's temporary, we do not need to update or add any recovery email, phone number. And once we're in, it is recommended by Quick Labs as well and the Google Cloud Platform. Once we accept the terms of service, not to click the email updates just because it's temporary, and the email sort of the account will be destroyed after that. All right, perfect. So once we are in, as you can see on this is just a little overview like I've spoken before. So just on the setup, the requirements over here, as we can see, once we start a lab, we just open and log in. So as we mentioned, we must use the credential in order for this lab to be success. There's a little checkpoints over here where it's tracked if you have successfully completed the lab all the way through the end. So first thing it says over here, it's recommended from Quick Labs to check the project permissions. But what I will do first thing is that, as you can see here, we have a GCP project ID. And once we are on the home screen over here, we can see we need to select the project, which means that currently we have no project. So what I will do is that I will go here, go under the all, and then find just the last one. Simply just find, if you're not already there, just simply find the one that is has a randomized number at the end. So if you select that one, then there we go. So now we are over there with that organization. Second thing we should do is that we should go and check whether we have the appropriate permission, which usually this one it is on to the IAM console. So we can navigate there from the little hamburger menu on the side. We're going to IAM, or just going like a searching on the top. So once we are there, so we just need to have the project number over there. So, and we should have the editor assigned. So if you see over here, this is the one that we have, and we can corroborate actually that has the appropriate permissions. So we can continue. We can simply go back to the home just by clicking on the Google Cloud Platform up there, and we are ready for the next step. So just a little check. Just gonna see if there is any question that you wanted. Okay, I can see that. Oh yeah, yeah. As Tim mentioned, if for some reason I can see that for some of them that actually saying that has been used and there's the same name as yours. So if you can just tick it out the box from another voucher and just use that one, and let me know if you would like for me to slow down a little. So maybe in the interest of time, although we have
Just for 5 minutes, let us log in because the token issue is not working.
yeah, sure, yeah,
Thank you so much.
no problem. So where to enter the okay, so once you're on the link, so if you're at the code lab, so over there on the start, you will be able to start the lab. So once you start the lab, there will be a little pop-up in the middle where it will say, would you like to join with your subscription or your credits, or you would like to join with access code. So what you will need to do is that you will need to type in the access code into those, I think there were like 4 little squares, and they just click join.
The CAPTCHA is expiring. The problem is with the CAPTCHA expires so soon till the time we enter the code. So that's why it says it's already used.
The CAPTCHA is expiring.
Yeah, it's done finally.
Yeah.
Yeah.
Okay, perfect.
Goran, should we pause until we can just confirm that everyone has successfully launched the lab with a code?
Yes, sounds good. Yes.
Cool.
I'm just gonna wait here for a second. So just once everyone is in, just please let me know. Just by drop a little line in the chat, just so I will know, and then I will go through the little intro again, just so before we start and prepare the Spark shell.
So is there anyone at the moment who has not yet been able to launch the lab? You can. Goran, can we put the link to the sheet back in the chat? I think some people may have joined after it was posted.
Yeah.
And if you are trying the other codes, please tick them off if they're not working, so that we can keep track of how many we've got left. If we run out of all the codes on the sheet, I can get some more.
So just gonna pop in the chat.
So if you joined late, you should be able to find your name on this sheet. If the code on next to your name doesn't work, just pick another one, but please tick the code that you're trying so that we know which ones people have tried.
Thanks, Tim.
Just in the interest of time, then, if anyone is still not into the lab, can you unmute and let us know? I think failing that, you're probably okay to carry on, Goran.
Okay, perfect. Thank you. Okay, so just for the ones that didn't manage to log in at the beginning, so I'm just gonna see a little set of requirements. So this is what you have gave it a little introduction before. So once you have a start lab, you have a temporary username and password that has been given to you by Quick Labs. So you'll be able to use the Google Cloud platform, which will be free of charge, just because you use that temporary account. So if you navigate to console.cloud.google.com and just log in with a temporary username and password, which has been given. And there will be a couple of pop-ups over there where we'll need to accept terms and conditions. All you need to do is just click accept for that one. Don't need to update or subscribe to anything, just because that's a temporary account and it will be shortly most likely destroyed after this, just because every account is unique. So once you're in, you should see the home screen, kind of similar to my one. It might be a couple of different resources or anything like that, but it should be mostly the same. Okay, so once you're there, it's the same, which is mentioned before. There's a preparing your environment. So there is a little on the top where in most cases it should give the GCP project ID, which is the up here. So if that one is not, just simply click, should be saying a selected project, just simply click on that, go to all, and use the one that has just the randomized letters and numbers at the end. To click that, you will be redirected to that one, and then we will be next thing is asking as well. Quick Labs is to make sure, just because there will be a service account in the use, so it's asking us to navigate to IAM and admin. So that's identity access management. So you have the navigation menu, all these little hamburger on the left. I just go there, or you can simply open search and then type it and just go there from here, which is same. So as you can see, there is a computation editor role. So this would be the project number that has been assigned, and over here you will see. So if you don't have, there's a couple of steps. 99% it will be there, but there's a couple of steps just in case that one hasn't been created that will need to be manually. So in the interest of time, I'm just gonna be going to the next step, which is to prepare the Spark interactive shell. So as you have noticed at the beginning, there has been quite a delay before we will be able to get those temporary username and password credentials. So that was because Quick Labs, what it does in the background, it provisions lab resources. In our case, we will be having the cluster for the for our Google Cloud Dataproc. So it just takes sometimes a little time for those ones to be provisioned, and once they are done, then we will be provided. So we will log in just so we will not go in to Google Cloud Platform, log in over there and just start with everything. So we can navigate over there just by going by the navigation menu, but I always prefer just searching, just because it's always, for me, the fastest thing. So once that one is open, it's going to be a little info panel. Just going to hide that one. Okay, perfect. So as we can see here, we have the cluster and two workers created for our Google Dataproc. So what it's asking us is that we click the SSH link for the cluster, and then we connect to the cluster VM via the SSH link. So over here down to connect, we should have a little SSH button. but just because if I would open that one, it will be a little harder for everyone to follow, just so I will be jumping through multiple screens. So what I will do here is that I will use view gcloud command. So gcloud is the Google Cloud Platform, I would say, terminal, and it's a cloud shell actually, where it's provided free of charge, and it's very, very, I actually love it to use gcloud. So it's just giving us the command, which is saying that, hey, you can use this command to SSH to this cluster who is in US Central 1A zone, and it is under this project, which we can see on the top. Perfect. So if you do run, this will open a little Cloud Shell. So as we can see, Cloud Shell is free for all the users. We just simply hit continue. It will be a little time just to provision, just because it's the first time. And there we go. We have the command over here. So what I will do actually is I will open the command into a new window and have that one zoomed in. All right, perfect. So this is what we have up here with the command. So once we hit enter, we will be prompted to authorize Cloud Shell to make API calls. So once we authorized, it will ask us, would you like to continue? We press Y for yes, go enter. It will generate a public and private RSA key pair. So just because for a passphrase, we don't really need, because it's temporary one that we would use. Just simply hit enter twice, and we're just going to show it. There we go. So our student ID, and we are connected to cluster M, which is what we need to do. Perfect. So a couple of things here we're preparing is that, just going to clear the terminal, is that we will need to create so-called environmental variables, which will be easier for the commands later on. These are good to be created, but it doesn't mean that it's necessary. But it's up to you. If you have a lot of, I would say, if you have a longer script or you have a lot of commands that you would use, let's say your project ID many times, it's good to have this one in an environmental variable where you will be able just to reference that one with $, and the project ID, and then we're going to be good to go from there. So we will have just copy that command. So in Quick Labs, there is a little copy to clipboard button, which once you copy it, you'll be able to paste it over. So that will be, so simply this, what it does is that it gets the value of our project, and it just added it to environmental variable called project ID. And then on the next step, we take that project ID and we export it to bucket. So just because we export it to bucket here, so bucket is storage, a Google Cloud storage where we can host. So since we export this to environmental bucket, that would mean that must be something over there created. So what if we do, if we go to the storage, that's a little typo, and then see what we have over there. Yeah, perfect. So once we see over there, we'll see, so there is a couple of Dataproc staging and temporary buckets created, and then that is the one that we have just exported to our environmental variable which has the name. So this one has been created in advance. So from the lab resources, one thing to note here is that the storage buckets must be unique across all the GCP projects in the world. So just because I have created this one and has been created for my project, if someone wants to go now and create a bucket called Quick Labs random at the end, they will not be able to create just because that bucket already exists. Okay, so we go back to our little Cloud Shell, and we just export zone, And in this case, it wants us to use US Central 1A. Perfect. So once we have everything in place, we could be able to launch PySpark just typing into PySpark. So PySpark, in our case, it comes pre-installed and pre-installed, pre-setup as well. So once everything is done over here, we should be seeing welcome to Spark as here. And as you can see here is that the Spark session, Spark context, all of that. So that comes. Those are actually declaration are only required if you want to use the steps in like any standalone code, as we can see it here. But great. So welcome to Spark. Everything is great there. I hope that's oh yeah, that's clear for me. I hope that everyone is able to see actually the good, or if not, just let me know and I'll be able to zoom in a little more. Okay, that should be fine. Perfect. So first thing we will need to do is we will need to import a couple of imports, so import and import, so to say. So what you can see here is we are importing from MLlib, which we saw that from Spark MLlib. We import logistic regression with LBFGS. So this is an import to train a classification model for binary logistic regression, right? So here we're using a limited memory BFGS, which BFGS is stands for 4 names algorithm, which I would never probably be able to remember. But if anyone is interested about that, just feel free to Google it and you will be able to see more details about it. And then we have a label point, which is actually the class that represents the features and labels of a data point. So what we need to do is just copy and paste. So once we paste, just because here in our here, so we have from.
Sorry, just interrupt you there.
Yeah.
That bit of code isn't there in I'm seeing. I don't see that logistic regression with BFGS.
Okay? Are you at the create a Spark data frame for training section? So you see on the side where it says create a Spark data frame for training. If you click on it, it will bring you there.
Right. Okay.
Yeah.
Okay.
Perfect.
Right. Okay.
Yeah. So just because here we have 2 commands, so we are importing these 2. So over here at the end we have the I would say the character for new line, and over here we do not have. Just because we have a character for new line, what is happening in PySpark shell that that character will execute that command. So if I do enter, so that command has been executed, but we are now standing on the second command and waiting for that command to execute. So if you just hit just hit enter, and we have executed. And even though we do not have any output, those 2 ones has been imported. So what we need to do next is that we will create a train data frame, but reading what it says here, prepared CSV already. So if you go inside here, GCP, so we'll see here is that we already have some data that has been prepared for us. So we have a train days CSV here. Then we go from inside here. We have another train day CSV. And I think we would need to, so we'll go into flights. So as we can see on the top, the buckets, flights, and train day. So I'm just going to copy paste this one, because I think here, just because here is a little truncated, I think here you will be able to see it better. So right now, as we can see, we are in the PySpark shell, and we have created before a bucket environmental variable, but we have created into our SSH shell on the VM that we have on the cluster VM. So what we do is that from the operating system, we take that bucket environment variable and we add it to bucket here as well. And what we do is we'll create a train days data frame, and we will read that CSV. So we'll read the CSV where in the header we will have true, and the CSV part is GS. So over here is where the bucket will go in, and then we will go to flights, training days. So if we hit enter, we should be able to import and create that data frame. Okay, so that looks like it passed through. Maybe we can corroborate if we do training days.show. There we go. So just showing the top 20, that's fine. So as we mentioned before, on the header true, so each train day, we have created all of them, imported and created all of them that they have true. So here, there's a step that it is necessary for this lab, but it's literally like not necessary in real world, so to say. So just because here create a Spark SQL view. So with using a create or replace, see. So create or replace temp view. So here we're creating, so to say, Spark SQL view. So if you want to store a Spark data frame as the table and query it, we will need to we convert that data frame into a temporary view. So this temporary SQL view is available only to this session, and the only purpose to this one is that we will use just to query and just do a couple of things. So this command, which says create or replace temp view, so what it does is actually creates a lazily evaluated view where it's that you can use actually like a Hive table in Spark SQL. So good thing to notice here is that this one will not persist into memory unless we cache the data set. So we're just gonna hit enter. That will be so we'll create a training days SQL Spark SQL view from our training days data frame. So just to corroborate a couple of things, we're just going to query the first few records in this one. So standard SQL query, we just select everything from training days and we order it by the FL date limit column. So if you hit enter, we can see the first 5 as we show you here. And we can see that if it's train day, if it's not, and just what is it, the date over there. So yeah, the first data. So once you have this one in line, what we do is that we create a schema for the actual flights data set. So this is something that has been included into one of the previous labs on QuickLab. So, but we can simply easily go with it over here. So what we can see here is that from PySpark SQL, we import what we can have for our string type. So sorry, for our column types. So as you can see here, we can have string, float, struct, and struct field. So all of these are the headers or are the columns that are provided or that are in the into the flights so-called data set over there. Just because there is a couple of differences here. So so we have a couple of differences just only into the types of the columns. So these 4, which is about the delay. So this is the arrival, departure, delay, the distance, and the taxiing for the flights. Those are float type in our case. So that's why it's just a little Python function where we can say that if the column name is equal to this one, we just return float type. If not, we just return to string type. And we just get that function and we just do a header split with a comma just because it's a part of the CSV. Great. So just to see if there is any questions, quick one.
Ask a question.
Yeah.
Why, when you did the show thing, it was not showing the other columns? Like I see here in the header there are multiple columns, but in it was only saying is train day true or false.
Yes. So because we have, so that those ones were the ones in the CSV. So I'm just gonna download it, that one, and hopefully I'll be able to show it. So in the CSV file over there, they should be only 2 columns. So just because we imported it, we can create a data frame from there. There should be only 2 columns over there, which should be, yeah. So as we can see, just we have when it was the time, and it was on if it was late or on time, literally true and false. That was the train day only data, which we contained only those 2. But then what happened in here is that it imported from the whole flights. So we have imported the schema for the whole flights data set over here. So that's why we are having all of those others columns, so to say.
Okay.
Yeah, perfect. So just gonna go back here. Just gonna see. Yeah, perfect. So what is the next stage is that we are kind of approaching that to sort of develop a logistic regression model. So for all of this, we will use the old flights, but we will use the old flight files that are labeled with 4 zeros, number 4. So just gonna copy paste the input here. As you can see, so we just go to the old, so if we go to this folder, TZ core, CORR, into the flights folder, and we should see all of the flights that are with 0004. So once we go there, we will see that there is plenty of files. So we're talking about 25. Yep. So if I click on, if I see over here is that we're going to see so just the 04, so just this one. So I think that we do not have another one. So because it has a subset of the full data set, and then this one can be also processed in a reasonable time. So that's why we are using only that one for now. So once you copy paste that one, simply we add it to an input variable, and we're creating that one. Hit enter, and that's it. Great. So once we've done that, and we have no errors so far, so we're just gonna read that one, and we will be able. So we will actually read. So we're gonna read from that CSV file using the schema we have created before, and we will create out that Spark SQL from that same data frame. Quite simple commands. As we can see, it's only 2 commands because we used it previously. So we create a data frame, and we read from that SCSV, which we have imported into a variable just before, and we have used here the schema which we have created just up here. So, and then we just create that Spark SQL. So, there's a little warning that it gives us, but this is literally for the logs. So it can be ignored in this case. So this is because there is a limitation on the logs. So because it was too large, this one has been truncated, and this becomes useful when you would like to export the logs, go through the logs and see where it is the error. But in this case, we can just safely ignore it, being honest. So next step, what we have is that, give me a second. So next step, what we do is that we're creating a query, as you can see here. So we create a query. We have where we select. So we select the departure delay, the taxi, arrival delay, and the distance, right, from those flights, but only where each train day equals true. As we saw in the previous, I think I'll be able to open this. So if you saw the previous, we have true and false from there. Even though it's a different CSV, we have the same data over here. So just we select just those one to ensure we will have training day data here. And that train data will be able to identify it as part of the training data set. If you enter, it looks good. So just because of here, just because a little output, just to make sure we have a couple of things over here, which is great. So the first row, delay was -2, taxi out, which is the taxiing time. There was arrival delay of 0, and we have a distance of 677 miles, I believe, in our case here. And there's another one as well. So great. So far, looks so good. Just checking with everyone if everything is fine and you have managed to get an output with the last command. Just because we are before moving on the next steps. All right, great. So there's a couple of things here. So first, as seen here, we ask Spark to provide some analysis of the data set. So there's a couple of good things here that we'll be able to see. So just because we're running on that train data, so we have described. So there's a couple of analyses that Spark will be able to run, such as count, how many we have, what is the mean, what is the standard deviation, what is the minimum, maximum. This is actually, when it comes to statistics, it's, in my opinion, it's actually quite good start. Whenever I need to work with any data, doesn't matter if it's even in Excel, to be honest, or in any other statistical program such as SPSS, so to say, I always go back and see where I am with the mean and the standard deviation, because you can get a quite good details of it. So a couple of things to note here is that departure delay, we have one number, taxi out, we have another number, then we have a different number, then we have a different number. So why is that? Because it looks like it's basically this ones, there is a lot of new values in, for example, this one has a lot of new values, even this one and this one. This one not so much, but still it looks like there is a new value as well over there. So when we come to ML, it's always good to have your data cleared, or so to say, yeah, I would say cleaning data. It's kind of like a first step when it comes just before you do your training on your model. So in order to do this, a recommendation from Quick Labs is that we need to remove flights that have been canceled or diverted. All right, perfect. So looks like the ones that have, so a couple of things up here. So the ones that has been arrival delay of 0, looks like it has been either canceled or it has been diverted in our case. So what we do, we're just gonna create a new train query where we'll be able to select from everywhere, select those 4 from our flights, but we would use the train data to true, but also if the canceled column is equal to 0 and diverted is equal to 0, then we will actually consider those. So as you can see here, we have already executed that one into Spark Sql View, and same as before, we just run. So what we should expect here is that the count should be the same across all of the summaries. So 159.45. That looks good to me. So perfect. So what I'm seeing here is that we have actually got rid of all the null, all the empty values, missing values that we have over there. And we have created here a little statistical data, which can be quite useful for us. So we have come to a point where we would like to develop a logistic regression model. So in opinion, one of the hardest parts, but actually it has been already completed here, just because we have managed to import our data, managed to clean our data, get a little mean, what is like a statistical summary. So just gonna see a couple if there is anything. Thanks, Tim. Has it already covered. So just let us know if so if when it comes to an event logging listener, you get the error over there. That usually means there is like an error with the event logging listener, but actually your actual command should went through. So I have actually I think just like a couple of days ago, I did a little test on my side for the lab, and I actually went through that error and it was good for me, but then the actual command went through successfully.
Yeah, the command went through successfully, but it's showing the listener error again.
Yeah, perfect. Yeah.
Okay.
All right, great. So we now come to a step where we're just going to start with develop our logistic regression model. So so what we can do here is that we're gonna create a function that converts a set of data points, and we'll just convert it into a data frame and into a training example. So we're just gonna copy on the other side what we have over here, and just gonna go through a little. So what we're gonna do here is that we're just gonna do our logistic regression. So where we would actually somehow look if the arrival delay is less than 15 in our case, and we're just gonna return that one. And the labels that we want to use is departure delay, taxiing, and flight distance in our case. So we're just gonna hit enter on this one. So a little thing here is that once you hit enter, that one is the one, but that hasn't been has been executed, but we're still not back to our Spark PySpark shell. So we just hit enter to go back. So make sure we have the 3 arrows pointing. That means that the command has been executed. We are good. So just need to hit enter again, so we'll be back. So all right, perfect. So once we've done that, over here we can see that we can map this training example to the training data set. Oh, so that actually looks and sounds like very, very interesting. So what happens here is that gives us a data frame for the Spark logistic regression model that we will be able to create that logistic regression model. So we just map that one to a map, and then here comes a time where we will be able to use the logistic regression with BFGS, what we said at the beginning. So there's a couple of things here. So we use our data frame to pass it and train our model. And because here we use intercept because our intercept parameter is used just because the prediction for arrival delay, as mentioned here, will not equal 0 when all the inputs are 0 in our case. So if we have a training data, well, all the inputs are 0 and the prediction should be 0 for that, then we should use intercept equals to false. So once you hit enter, we can see that we have already, we will be having our linear, also our logistic regression model trained and ready. So this can take a little, but it's not that's going to be that much. So if you see here, there is a little error, so failed to load. So that sometimes happened. So if you're going to try it again, that should go through. Even though, even if you have that one, though, it's just a warning. That means that some implementation failed to load, but it doesn't mean that it's directly affecting ours. We can simply do that. So next thing we have is we have our print command. So in print, we will be printing the weights and the intercept of our logistic regression model. And we should have a couple of things over there. So as we can see, these are the weights, and this is our intercept when it comes to the our logistic regression model. So we have created our data frame. We have passed it to our model. What's the next thing to do? Well, the next thing to be done is literally for us to have a test on that model and see if it's going to come true. So what we have right now is that we can test directly. So some couple of prediction, right? So if you go here, so we're going to predict. So we are passing the parameters. So the parameters we use first is departure delay. All right. So we have the departure delay is 6 minutes. The taxing has been 12 minutes, and the flight distance has been of 594. So we are considering all of the flights to be like on time if it's less than 15. So what happens now is that once I hit enter, I should get a result of 1, which means that hey, the model is quite confident actually when it comes to this case that this flight, just because it was having departure delay of 6 minutes, it means that it will arrive on time. So it gives us the 1 here, which is great. Another one that is that we can test right now is that what if we go the same one and it's the same, but what if we right now we have a large departure delay? So 36 minutes, it's a large departure delay. So if we hit enter, we hit 0. So our model is quite confident that our flight that has departed 36 minutes late will actually arrive late, which probably most of the times I think it's true, but there's a couple of things here as well. So we have only we have 0 and 1, which is like yes or no in our case, but this one can be returned like true or false, and it's like set by a threshold. So this is set by default to 0.5, as we can see here, and we can clear the threshold and we can run again. So there is here ILR model. So we clear that threshold, right? And then so now for the ease, just gonna copy it from there. So now when we print ours, we have the we give a better probability actually if you would like to use that. So just because before we had 1 and we had 0, here we can see we have a 0.95, which is like a great probability. And here, just because we have a second one should be close to 0, which in our case is 0.102. And this means that in our 2 sort of test data, our model actually it's how to say it, it's actually giving us quite good results. So I would say it's good to be used. So what happens is if we set the threshold to 0.7, right? So if we set the threshold to 0.7 and we print that one, so we have 1, which is great, but 1, and then we have 0. But now our outputs, they are reflecting on the 70% threshold, probability threshold that we have set, which means that, hey, everything that's over 70%, we are good, but everything that's below 70%, no, can do. That's going to be late. So this is a little thing that is actually good to be experimenting. So for example, if you would like to have your threshold, so if you're working with a very sensitive data and you cannot, for example, like you have, let's say, work in an airline and you would like to see all of them that has been late, but you would have a threshold of, let's say, 0.8, you will be able just to clear that one, set it to 0.8 here, and then just print, then it will give you the output. So that is for creating and use the logistic regression model. And we have a little testing. So the last one what we have here is that we have the save and restore. So just because we have created a model, this model hasn't been saved anywhere because we are having this one sort of in the memory. So if you would like to save a model right here, so first of all, here it's saying that we should not have that model already saved into that location. So the model file here, environmental variable, we are actually saving the output path to it. So this will be into Google Cloud Storage and should be inside flights and Spark ML output. So if you would like to, yeah, thank you. So if you would like to go back, so if you go here, we go to flights. So we can see here that the one that is requested, Spark ML output, is not here. So even if we have it, it's better to rename the model. So what you do is just use the os.system, which is operated, you just write the file. So you just execute this one on the OS level, and we use the gsutil command, which is Cloud Shell command that is used for actually it's used for a Google Cloud Storage. So what happens here is that the first command is for the gsutil. So this means that -n is that you are free to use sort of in a parallel. So you'll be free to use more files. I think it's the term concurrency. So the concurrency is on, which means that you will be able to copy multiple files at the same time, and then you just write those one over there. So the recursive R here is just for the whole directory. So just hit that one. Yeah. So what we have here is that one object could not be found, right? Because we have not saved yet the model. So one thing is that first we need to save model to some model file format, and then we will be able to that one. So we just execute the command to save. Yeah, and then we just print and see if that one will give. Hey, great. So we can execute a command to save that model over there, right? That's great. So what if we do, if we go there, do we have anything? Oh, great. So that model has been saved, and we have it here into this folder, so to say. So another thing is that we can destroy the model object in our model, and we can do this by running this command. Great. So the last thing that I'm just going to show you shortly, and then just going to give a little on the other side from the for the PySpark as well, is that we retrieve the model from storage. So as we can see here, we will need to import a couple of so we import the logistic regression model from our MLlib library, and then we just load that one. Just because we have the model file still in memory, we are able to load that one. So SC, if I scroll all the way to the top, actually we did not execute this one just because it was Spark environment. But if you see here on the top where we have started, there is a little so the variable SC. So you can see they are pre-configured over here, which SC it stands for Spark Session Builder. So that is great. It's already been here. But if you would like to use somewhere else, let's say we would like to use this one in any notebook, Juniper notebook, for example, we would need to have that SC imported or pre-configured before running. So once load that one, I will set the threshold to 0.7 as before, and then we just print, and we would see that we would have the weights. So if we try to print even the intercept, then we will be able to have that one. Just a little test at the end, we'll be able to corroborate that our same model has been loaded. We have 0 for the same 36 minutes of our departure delay. And if you would like to change that one to 6, we should get 1 as mentioned before. Yeah, there we go. Perfect. So just at the end, this is just a little cleanup. Once everything has been done, we can just hit exit just to go outside from the PySpark shell, and then we will be back to the SSH from that cluster. So that's pretty much all of it from the lab. Just a quick thing that you will be able to use Dataproc. Doesn't necessarily need to be from a shell. So as we can see here, this is the cluster that is running on the VM. So you can create a jobs here. So I have used these ones quite extensively a while ago by submitting jobs. So this is quite good when you have I was using with Spark R, and it's quite good when you have any, I would say any repeating jobs, but your data, it's changing. So sort of like you get a new data. So it's like you would like to run those one and save it somewhere to a file or anything like that. It's very great. You'll be able to manage quite good, and it's actually everything. So once you create a job over here, everything's automated. So you would need to ensure that you import everything that you would need, that you will be able to do everything you would need into that job, and then you will need to clean any resources at the end, just because everything runs, I would say, simultaneously all at once. So we have a couple of workflows you will be able to do. There is a notebooks here, so which is the one. So you will be able to open, as we can see here, a Jupyter as well. So not going to go too much into detail into that one, just because of not having enough time, but we can go in here and you can do it via console. So you have a PySpark, you can do it on the console. So another thing here is that, like, if we go to, I'm just going to show you quite a little on this one, is that another thing to bear in mind when it comes to Quick Labs is that if you go away from your lab, I would say from your lab scope. So if I say I would go and I would spin a couple of more VMs that I would need to use for something else, or I would go to BigQuery and I would like, would run SQL queries on any public data sets, you might be blocked and from the Quick Labs, just because there is a certain terms and condition that you need to follow and should not go out, should not go out a lot from your environment. So over here, we just created a couple of things, right? Which is like, okay, we just need to, so a couple of things. So if you see here, we did not run over there. But if I would come and here, and I would, let's say, run something. So we don't have it here, but over here, we're just going to delete a couple of things, right? So we're just going to have that one. So if I would create this TCP project, and I will go here and I hit enter, let's shift and enter. It should give me a couple of errors when it's gonna. So here we did not, just because we have already loaded, but when you're gonna continue and run our lab and we do not have the Spark session and we not have the Spark context, then next thing what we're gonna see is they're gonna be seeing an error where it's gonna ask us to import this one, just because this one hasn't been automatically imported for us here. So not gonna take too much time or for the time of this one. Just gonna close it. When it comes to here, we can simply exit and we'll be back to our Cloud Shell. And good thing to see here is that we have a score 5 out of 5, which means that everything that has been required from us in this lab, we have completed. So only thing we will need to do is just hit end lab. We can do a little feedback if you would like here. It's up to you. But then what I would do usually is that I would close the tab and then I would just sign out from here. Just because, for example, if I would like to run another lab and I don't want to go out from incognito, then I'm just gonna remove the account from here and then I can start from a clean first steps, so to say. So that's pretty much concludes our lab for today. Not sure if anyone has any questions. So at this point, I think we're gonna stop streaming out to YouTube, just because we have covered everything that needs to be covered today. But we will still be able to stay if anyone has any questions regarding the lab, or anyone has encountered any errors, or has maybe received any different outputs than the one mentioned in the lab. So yeah, if anyone has anything, feel free to ask us. Me and Tim are here in Zoom. I think Ricardo will soon join us as well. So yeah. Thank you, Ricardo. Yeah, I think we are good for the YouTube Live. I just wanted to let you know, just because this one has been this workshop has been created with a combined effort from the dev party team, which is from different GDGs and DSC across the UK and Ireland. You'll be able just to go search on YouTube for our dev party YouTube channel, and go there. You will see the recording from today. And also, if anyone has missed, you'll be able to see that from last time recording that a team did on Kubernetes, which was quite great. And you'll be able to watch it on your pace, so to say.